too. Ladies and gentlemen, I have saved the best for last. My favorite team is Maroon, and she has built the Tomobot.
Hello everyone, this is Mara. My team's Michael, Carney, and Marita. Hello everyone, this is Mara. Okay.
All right, stop. You're killing me.
Hello everyone, this is Mara. My team's Michael, Carney, and Marita. Today we just present for you our robot named Tomobot. Our Tomobot, the purpose of the robot is learning for kids to like coding for Scratch or other programming language. And then the other purpose of our robot is for recording a movie or a music. You can put the device on the top of the robot so you can record a music or a movie around the house or around the stage. So that's the purpose. So Carney, he can explain for you about the programming language.
So we chose C# as our coding language to code the robot to automatically roam around the house. And as presented, this is what it goes with. So if it uses the sensors at the front, so if the object in front of it is struck with the sensor and detects it, it demonstrates a sound. So we put a sound with the atomic sound. And then the next part, it leads to, see the Tomo detects an obstacle, and then it turns left, and then it picks a random position, and centers it, and then continues to go after that. So right here, as well as right here, using the sensing command as well. And our last piece, this is another part of the detecting process. And it also projects the sound. Whenever, it'll keep repeating the process as well. If it detects an obstacle in front of it and senses it and goes around, it continues to go around forever. I'm going to pass it to Marita.
Hello, I'm going to explain how the hardware is combined together and how it looks like when you look deep inside and internally. So the two A's that you can see right here, they are the sensors, ultrasonic sensors. Whenever the robot that you can see when it travels in some direction, when there's like something that blocks it, it sends a wave to the block, and then when the wave comes back, the controller right here, as you can see, controls it and processes it so that it can detect and turn back and turn right too. So the other thing you can see, as you can see, there are like motors here, which takes like a battery, like AA batteries, and turns to mechanical energy. And we have like three sensors generally. The one that is inside right here, the black one that you guys see, is called the tracker sensor. The tracker sensor is basically tracks the black line. When it goes through the black line, it tracks it, and it keeps the robot moves to that black line, so it can be going right. And we have a gyro sensor inside. As you can see, we only have two wheels here. That's because we have one wheel here, and we want to use it. It's called dicycle. We wanted to do the bicycle, but we wanted to try the tricycle because it has a sound feature in it. And we did two wheels so that there's a gyro sensor inside this robot, which can balance the robot when it goes in some direction. So this is there's like a microcontroller here inside, and the Bluetooth sensor too, so that like we connect with our phones with the Bluetooth and program too. So the pros and cons that we have when we do this project is, the pros that I can say is we had the knowledge of Scratch coding so that we can be able to code it easily, and we have the manuals that helps us to construct it when it came to our home. So the cons that I can say is we didn't have a lot of time to process it because of the holiday that we had. That it came in like early. So that's generally what it is. I would like to pass it to Michael to talk the different features and like how is it gonna look like when it comes to Android and iPhones when we program it.
So I'm going to be talking about the Android perspective, and the Android perspective is basically they kind of made it a bit easier for the youth to use for the Android perspective. So you'll be having chain functions where you can control the length of time, you can control if there's alerts, which direction you want to go, the speed, the angle and trajectory. The main difference is just the way that it looks. So for the iPhone perspective, you have it's like scratch code. So you're going to be having a list of functions where you get to control the seconds for how long it's going backwards, the steps it's taking, and everything else. For the Android perspective, you're going to be having like a remote control function that you can have. So
okay, we can show you the iPhone version 1.
So for the function, I'm going to connect to my Bluetooth, and there's going to be a remote control function I can use. That's it's only on the Android, so I can control this remotely by my phone. Nice.
So what we're doing right now is connecting to the robot right here so that we can see how it's gonna be when the when Android version and there's like an app that's easier for kids to control it just without even writing a program and everything. So there's like remote control, this one. And then we're gonna show you how is it gonna look when it comes to the real coding that we did. This is the coding that has been there like easier for kids to try it. And I'm gonna close it and open it so that it's easier for connecting again, so that we can try it on the remote control device. I switch it off. I'm gonna switch it on right now. Just gonna go ahead and connect it to the Bluetooth and let's get it. As you guys see, it's following the black line through. So that means that like we assume that whenever this robot will be applied, there should be some certain way that this robot should go, so this robot follows the black line.
And if you don't want to use the code, you can manually control it with your phone here.
That's the manual control. You can adjust the speed if you want to. You can necessarily make it follow the direction that you want it, so it can have its purpose.
The lighting's changed, the amount of how many lights you want on its back. You can also put it on roam mode, which lets it allow it to go anywhere you want it to.
Alright, so this is pretty much the functionality through the remote control. So even though we didn't have a lot of time, we tried to code a little bit on our part as we can. So Miron is going to show you guys how to control it through her device. Let's restart.
It's a kind of a little bit difference if you use the iPhone and then the Android. That's the only difference I'm going to show you. I'm just using an iPhone now to control the device.
As you can see, there's a sound it can make when it turns around. We did it on purpose so that it has different functionalities.
And when we do this project, there was some difficulty. We just tasted last Sunday, it's work or not. It was work very perfect. And then we just bring it here last Monday, but it's not working. So when something is moving inside, so it was changing the environment. So sometimes it's not working, so you have to like taste it right away when you use it. So you know it's working. So it just, when they're moving inside, it was stuck in some of the port thing.
And as you can see, just to let you know, there's a lights here that you can make. We can change the lights based on what we want it to be. So it's kind of like our choice to program it. So we just made this one so when it turns around to show this light, the microcontroller got lights, leads of lights just around it so that we can control it through our device by programming.
Yeah, our processes look like this. If you guys have any question, we can accept any question.
Here, question. It's a very big project. My question is, what kind of microcontroller do you guys use? I mean, what type of microcontroller?
So the general point on this is we got the microcontroller, but we are not sure the microcontroller what the factory provided us with. But it has its own like functionality that that's really similar with the different microcontroller like Arduino Uno and Raspberry Pi 2. So not sure what the name of it is.
But it calls ODVE actually.
ODVE?
Yeah. But it's not popular like Raspberry Pi or the other one. Anyone?
So when you were coding and you were coding it, you said through Scratch, and you can also code it towards like real
JavaScript.
Right.
Yeah.
So through JavaScript, which one was like more difficult, and which one had more functionality?
The Scratch when they do it, the robots, they have an app you can download it and then use it as a Scratch. So that one's very easy to use it. This one is just do it like for kids for 8 years or like older. So if you are 8 years, it's easy to understand the Scratch code. So it's easy, very easy to do it with the Scratch code. But it's a little bit difficult with JavaScript.
Yeah. So in JavaScript, you have to basically convert the functions from the code in Scratch to JavaScript, and then you have to basically combine it together. And it looks really like unorganized and kind of confusing, and that's why it's a lot more difficult than doing it in Scratch. But we did it in C# way.
Any other questions?
No.
Okay, thank you guys for listening us. Hello everyone, this is Meron, this is my team, Michael, Barney, and Meritab. Today we just present for you a robot called Tomoboto. Our robot is just two drives, like a kind of bike, whereas the purpose of our robot is just learning for kids, can learn to coding stuff, and the other purpose for our robots can, if you are a movie industry or music, you can put it like a device at the top of our robot, and then you can record all the way your house. Like if you are like a music concert, and then if you want to record it, you can put the record machine at the top of our robot, and then you can record it.
Stop.